Polynomial functions or not. On this page, you can see 7 different examples, and your job will be to determine whether or not these examples represent polynomial functions. For that to happen, you need to learn a few things. For instance, if you have a fraction in the exponent, okay, so if you have a variable raised to some sort of fraction, then you're going to say it is not a polynomial function. Okay, so you're going to keep looking for fractions in the exponent and say, no, thank you. For instance, let's see, where would we have a situation like that? How about here at the bottom? Number 8. You see, x is raised to the power of 2/5. That's a fraction. So that would disqualify this whole thing from being a polynomial function. Another stipulation is your exponent is not to be a negative number. If you can find a negative number in your exponent, you say the given polynomial is not a polynomial function. So what's happening? Do I see a negative exponent? In these examples, 1 through 8, I actually don't directly see that, but perhaps I can make it visible. So start thinking about what does it mean when I have some variable raised to a power in the denominator. Okay, so that's something to consider, and we'll get back to that. Once we have gone through the lesson, you will be able to determine your 1 through 8 as polynomial function or not. So what we want to understand further is, do I have a function that is even, odd, or neither even or odd? Okay, no, so not even, not odd, we would say neither. So how do you determine that? Okay, so let's take a look. If you have an even function, you'll be able to do the following. You plug in negative x, and you would still get the same as your original used to be. So here's an example. Example number 1. Take a look. You have f of x is equal to x to the power of 4 plus 3x to the power of 2. When we plug in any negative number, in fact, the output will still be positive. So let's just plug in general and negative x. What happens? Check it out. Did anything change? F of negative x shows the same result. Therefore, my original function is considered an even function. Now let's observe the exponents. What can you tell me about the exponents? X to the power of 4, 4 is an even number, and x to the power of 2, 2 is an even number. Does that have to do with anything? Obviously, yes, because a positive even exponent will create this situation right here, where your negative x, when raised to an even power, will turn positive. Therefore, there was no change in your original situation. So let's look at example number 2. What changed? A couple things changed, including my exponents. They don't seem to be even anymore. Let's perform the same experiment. We're going to plug in a negative x and see if we still get the original. So as you plug in your negative x to the power of 5, what happens? That's like negative x times negative x times negative x times negative x times negative x one more time. And when I have an odd exponent, my negative remains negative, in fact. So here's what happens. Instead of both numbers being positive, both terms, I mean to say, as they used to be in the beginning, look what happened. They both turned into the opposites. So my original did not remain the same. In fact, it changed to its opposite. Therefore, I can also factor out the negative, by the way, you see? And that's why I can write it this way. F of negative x resulted in the opposite of f of x. And therefore, we call it an odd function. Okay? And the exponents were, in fact, odd. Very odd things happen. Let's see. What kind of function is this? Okay, so you are to decide. Number 3, what do you think is going to happen? It says f of x is equal to x squared plus 6. 6 doesn't have an exponent at the moment, and it doesn't have a variable to it. Maybe it does. I could say 6x to the power of 0. Notice? I can do that. Well, is 0 odd or even? What's happening? Well, it's neither positive nor negative, but it's definitely not odd. So let's see what happens. I'm going to add, I'm going to plug in negative x into my original and do exactly as it says. Negative x to the power of 2 plus 6 times x to the power of 0. What happened? 2 times, 6 times negative x to the power of 0 still turns into 1. Anything to the power of 0 is 1. So that's like I keep my 6 as is. And that means, wait a minute, what happened? Negative x to the power of 2? Oh yeah, it remained positive right there. So somehow I kept my original. And that's when I say it's even. All right, example 4. Example 4 shows odd exponents both ways. When it says f of x equals 2x to the power of 3 minus 10x, it means minus 10x to the power of 1. Okay, so notice this. So I identify my exponents as odd clearly, and I investigate further and I notice, yes, indeed, it did change into its opposite. Everything switched into its opposite. And therefore, I have an odd function. Good job. Number 5. Last one. I have a mixed situation. Notice that I have odd and even. This one would be even as well, x to the power of 0. And what happens now? Neither. You can perform the test and you will notice that you have a mix of things going on and it's no longer one way or another. So it's kind of not here, not there. In summary, what actually happens with even functions? What does that even mean? Like, how does it help me? It will help you determine the end behavior of your function, the end behavior, that is, and you will be able to predict your graph, what it's going to look like without the calculator. So, for instance, with even functions, you are going to have the legs of the graph will point into the same direction. Same, meaning either both pointing up or both pointing down, depending on your leading coefficient. Okay, but for this example, it's y equals x squared. Notice it is the parent function of a quadratic, and the a would be 1. Therefore, it's going to point up. Okay, it opens up, and both legs will point into positive infinity. Oh, okay, so that's what even functions do, right? They point in the same direction. Now, more importantly, you also want to see what actually happens when it comes to the symmetric behavior of the function. Even functions are symmetric about the y-axis. And what does it mean? Well, this is your y-axis. You can fold your parabola across the y-axis like that, and it will reflect on top of itself by using your mirror line being the y-axis. Now, how is it true for horizontal lines? Check it out. Y equals -2. Okay, so what's going on there? Fold the line across the y-axis and it still will coincide and be on top of itself. So therefore, yes, you have those even functions. What about odd functions? What do they do? Let's take a look. Odd functions, will they reflect or be symmetric about the y-axis? Not so fast. Actually, it's like a double situation. Reflect over x and y. And therefore, we say they will be symmetric about the origin. But really, it's like reflecting down to the side or to the side and down. So it's a double reflection. To keep it short, we say it's a reflection over y equals x. Okay? That's what odd functions will look like. And notice the legs go into two different directions. Okay? They don't point into the same direction anymore. Odd functions the legs go separate ways. All right, and then you still, of course, have to observe what your leading coefficient is and which way it's going to go. You'll practice that some more. Let's go back to the first page. Can you tell me if we have a polynomial function or not? And then odd or even. So please practice here so that you get to apply what you just learned. Do put the missing exponents in here. Okay, so if something is missing, you can just go ahead and add that so that you can easily see what's going on. You can even put x to the power of 0, and if that's what you want. First of all, is it a polynomial function or not? Let's see. Odd and even and neither is not a problem. It still is a function, polynomial function. But look at number 6, 7, and 8. What wouldn't work for us? Go ahead and rewrite it. Use your rules of exponents to recall what that means. Uh-oh, I got a negative exponent. That would not be a polynomial function. Okay, what about number 7? Square root. A square root means my index is 2. Okay, if there's nothing visible here, that means it's a 2. Okay, it's a 2. Square root. And that means actually 6 to the power of 1/2 minus 3x to the power of 1/2. That would produce a fraction, and therefore it is not a polynomial function. And on the last one, it's clear to see you already have a fraction and you're done. Okay, that's not a polynomial function. You can still graph. You can obviously, you will still get a graph, but what kind of graph? Okay, so that's something to observe. Let's go to number 1, 2, 3, and 4 and see what happens. One thing is for sure, 1 through 4 are not vertical or horizontal lines. Okay, none of that. Number 1 seems to be actually what kind of function? Oh, that's a quadratic function. It will look like a parabola. Okay. Is it odd or even? Oh, I have x squared and I have x to the power of 1. So it's going to be neither. Will it? Okay. But which way will the legs open up? Let's think. This way or this way? Look at the coefficient. It's a -2. So it's going to be pointing down. Okay, so that will be a parabola. Now let's look at number 2. What's happening? Odd or even? Definitely odd. Okay, it's going to be somehow like this. Okay, somehow like that. You can use the calculator to explore first. We'll learn much more about it as we go. Okay, that means y equals x. Wait, that's linear. Well, we know that. And that's odd. Oh, what does that mean? Goes into 2 different directions like that, right? We know that. Number 4. What's that? What is going on? Definitely odd. So how about maybe something like that again? Okay. Leading coefficient is positive. You can use the calculator to check. This is y equals some number. What does that tell me? That's a horizontal line, guys. Horizontal line. Okay. And is it odd or even? X to the power of 0, we're going to call it even. Okay. There you go. I hope this helped. Review, ask questions, come for tutorials.